Hello, in this video I'm going to go through the first part of the 2012 Oxford PAT. I don't think anything has changed here from the previous few years when we're back at this time of the papers. We've got no calculators, we got G is 10, we want exact answers for the first part, which is going to be the maths bit, and two significant figures for the physics bit. So let's just crack on because these take quite a while. Find the area between these two curves. Okay, so a quick sketch of this is going to help us visualize what's going on. We've got y equals x squared, and then we've got y is mod x, so that's unchanged for positive x, and then we're just making it positive for the negative bit of x, so as in we're reflecting it in the y-axis there. And we've got to find this area between the two of them. So when do these intersect? I mean, we're symmetrical on either side, so we can ignore the negative side. Just do double the area on the right hand side. So we need this intersection point, which is going to be when x is equal to x squared. So that's going to be at 1, 1 then. So we need to do an integral and double it from 0 to 1 of the top one, which is x, minus the bottom one, which is x squared. So this should be quite straightforward now. X squared over 2 minus x cubed over 3 from 0 to 1. So it's going to be a half minus a third is a 6 multiplied by 2 gives us a third. So yeah, a nice sort of standard A-level type question to get us going. Write down the binomial expansion of 4 plus x to the 4. Right, 4 plus x to the power 4. So we do our usual systematic approach to that. We're going to need 4 to the 4. I'll put in the coefficients later on. 4 to the 3 x, and then 4 squared x squared, and then 4x cubed, and then x to the 4 at the end. So that's all the 4's and the x's, and then we've got 1, 4, 6, 4, 1. So 4 to the 4 is 16 squared, which is 256. Then we've got 256x, 6 16s are 96 x squared, plus 16 x cubed, plus x to the power 4. Right, so that was relatively painless for that one. Hence or otherwise, so we'll go with hence, work out 4.2. Oh dear, right, to the power of 4, 2 decimal places. All right, so it's only 2 decimal places. They haven't asked, they did say exact for all of these things in the blurb at the start of the exam, but still, they've changed it for this one. But I don't think it would have been that hard anyway to do all of this in one lot. Right, one thing to say about this, I suppose, as much as I'm a fan of fractions, changing that to a fifth is just going to be a pain because we're generally better at doing powers of 2 than we are at doing powers of 5. So I think let's keep that in decimal form. Go with that. So we've got 256 plus 256 times 0.2. So that's a fifth of it, which is going to be 51.2. So fifth still comes in handy, I suppose, every now and again. 96 times 0.2 squared, so 0.04. Let's work that out in a minute. 16 times 0.008, and then we're going to have 0.008 times 0.2, which would be 0.0016. So what are these things then? That's going to be 4 times 0.96, which is 4 minus 0.16, so 3.84 on that one, which leaves us with this 16 times 8 times 10 to the minus 3. So 16 times 8 is 128. So we've got to drop back 3 decimal places to that. Okay, so we've got all of those. So that is 307.2. And then we've got to add on all of these bits plus 3.968. We're only going to 2 decimal places, so hopefully that last bit won't even matter. So that is going to be, what we got, 310, 311.168. and then we add on that, so that would be 96 at the end. So to 2 decimal places, we've got 311.17 to 2 dp. Okay, that wasn't that bad, but that's the thing with twos. Generally, people are happier with doubling and halving things. Right, what are we on to now? We're now evaluating this. Right, okay, this looks like it's something that's going to be a bit too annoying to just sum everything up, probably. Like to write out all the terms. We've got 2 bits here. I mean, for this first part, we're just writing down 2 8 times because it doesn't depend on r. So we've got 16 there. That bit is 16. And then we've got this geometric sequence for n terms. So sum to n is a r to the n minus 1 over 1 r minus 1. So that is going to be equal to 4 times 4 to the 8, wow, minus 1 over 3. Jeez. Right, so we got to work out, so that's 2 to the 16, 2 to the 18, minus 4, all divided by 3. That's a lot to work out. Right, okay, so I mean, one advantage that we do have on this is a lot of people can remember 2 to the 16 is 65536. Yeah, it usually comes up if you do a lot in, well, either computer science, because these sort of things come out in memory sizes, or, well, I suppose back in the day, the people who used to use the old versions of Microsoft Excel, that was the maximum number of rows you could get in it, until they turned them into mega spreadsheets as they are nowadays. So it's a number that sticks in the mind. I mean, if it doesn't stick in the mind, it doesn't take a lot to go through all the 2, 4, 8, 16, 32, 64, 128, 256, whatever that is, 512, 1024, 2048, 4096. I mean, we've already got up to 12 there, so we've only got to do a few more. 8192, 16384. They're very easy to double. You've only occasionally got to, you know, sort of roll over a number, and then we're up there to 2 to the 16 already. I mean, we do need to get up to 2 to the 18, so we've got to double that again. So that's 131. And then we need to take that little bit of extra, so 131 and then 076 at the end, and then we can double that again to 262144. So that's what we've ended up there. Take the 4 off is going to give 262140, which we need to divide by 3. So that is going to be equal to 8. Carry 2 means 7, carry 1 means 3, then 8, then 0. 87380, and we have to add on the 16. 87380, 87396. Right, so that was pretty good. I like these sort of questions because it stops people completely losing track of how numbers work. So, I mean, it's quite a lot for 3 marks. But I don't mind that sort of thing. Right, consider a square inside a circle of radius r as shown. What is the shaded area in terms of r? Okay, so we've got, if that is our r, then we've got pi r squared minus, and then we need the area of the square. So if we've got the diameter being 2r, and if you square the diameter, then you get twice the area. So we need to do a half of 2r squared and take that off. So that's got r squared, we've got a pi minus 2. So that was pretty easy. Question 5. Show, all right, we're sticking on the easy ones here. We just got to factorize this. So we can show that is a solution just by sticking x is 1 in. 1 minus 6 minus 9 plus 14 equals 0. So tick. So we've got x minus 1. And then we're going to have, we need an x squared. We need a minus 14. So we've already got minus 14x, so we need to get a plus 5 worth of x, so we're going to need a minus 5 there, and then we can factorize that last bit, so that's going to be a minus 7 and a plus 2. Plus 2, put the equal zeros in, so we've got x is equal to 1, 7 or minus 2. Right, so they've given us two quick ones after a pretty tough start. So find the equation of the line passing through 0, 2 and just touching this parabola here at x is greater than 0. Right, so it makes me think this isn't going to be on the parabola the way they've said it, and if you put 0 in, you get y is 4. So yeah, that's not on it. So let's do a little sketch then of what we're actually playing around with here. We've got our parabola, which is going to be sitting 2 off to the right from where as a transformation. So we've got that, and we've got this point 0, 2. Okay, so there's two possible. Oh, that's going to be a straight line going up there. I'm struggling to draw it at that angle. Two possible tangents that we can get, one here and one here. So we need to work out something to do with those, where they're intersecting, which is going to give us multiple gradients, but we also need them to be tangents and not cutting through the curve. You know, we're not doing that. So let's see how that pans out as we go through everything then. So let's call our straight line, well, it's going to be y equals mx plus c. We don't know the gradient. We know that c is 2 because that's there. So we've got that, and that has to be equal to x minus 2 all squared. So we've got mx plus 2 is equal to x squared minus 4x plus 4, which gives us a quadratic of x squared minus, what is that, 4 minus m, so 4 plus m times x plus 2 equals 0. So this is going to give us intersections based on, well, based on what m is. I'm trying to think what this is going to mean on all of this. Yeah, it's going to, so for a particular m though, for a particular value of m, we only want one intersection point. That's what we're after here. You can't have, okay, we don't know what m is going to be yet, but we can't have more than one, because if we put this into the formula, we're going to get x is 4 plus m over 2 plus or minus some whatever. So that needs to be, this bit needs to be 0, otherwise we're going to get multiple solutions for a particular m, and we can't have that. So we need our b squared minus 4ac to be 0. So we need 4 plus m squared to be equal to 8. So m is going to have to be equal to 2 root 2 minus 4 when we square root on that. Oh, and we're going to get two possible answers here, aren't we? Because we got a plus or minus. Oh, and that's going to be our two. No, we've got that one, which is very negative, and that one, which is less negative. So it's going to have to be the plus. We can't have the negative one. And yeah, if we put in, so if m was equal to minus 2 root 2 minus 4, then we're going to get x is less than 0, which is clashing with that. So yeah, we can't have that. So m is going to have to be 2 root 2 minus 4, which leaves us with, we just wanted the straight line, didn't we? So yeah, y is equal to 2 root 2 minus 4 times x plus 2. So that's pretty difficult, I would say. I mean, these have been a difficult bunch already with a couple of exceptions, but that one I think has been the hardest one so far. Question 7, right, the log ones are normally easy. So if 5 is equal to that, okay, we just need to solve that for x is what they're saying. So we've got 5 is equal to log base 2 of 16 is 4. Log base 10 of the square root of 0.01 is going to be a half of minus 2, so minus 1, plus log 3 of x. So we've got 2 is equal to log base 3 of x, so x is equal to 9. Right, yeah, that wasn't how they give 4 marks for that. I have no idea. I mean, they gave us, what, 4 marks for all of that. I mean, this is just basic stuff, but the log ones are always really generous. Right, the dice ones are normally generous as well. Right, consider 2 dice. One contains the numbers 1 to 6, the other contains only 1, 2, and 3 shown twice. Okay, what's the probability when we roll 2 dice we get a score of 7? Okay, so we can either have a 1 plus a 6, a 2 plus a 5, or a 3 plus a 4. So that is a third times a sixth each time. So multiplied by 3, which is a sixth. Again, 4 marks. Wow. Okay, I suppose you've got to take them where you can get them. Question 9. Solve that. Right, okay. Leave it in terms of sine theta. So we've got cos squared 1 minus sine squared. So we'd have sine squared theta minus sine theta minus 1 is equal to 0. So sine theta, I'm just going to go for the formula, is 1 plus or minus the square root of 5 over 2. Well, it can't be plus because that's outside the range of sine theta. So sine theta equals 1 minus the square root of 5 over 2. And at least that's in the range of minus 1 to 1. So, yeah, another really easy question. Right, I suppose I had to put some in, considering how difficult it was at the beginning. Right, question 10. Sketch an example of a real function f of x defined for all real arguments x, which has all the following properties. So it's always greater than 0. Okay, so let's not put in a negative on the y-axis. Well, I suppose I have, but let's just leave that bit out. It's continuous, right? So we've got no asymptotes, no jumping around. df dx is equal to 0 and only for x equal to 4. Well, let's make it a minimum then, because then it keeps us away from everything being negative. That seems all right, doesn't it? That's our only 0 gradient point. I mean, I suppose you could have it being positive and then go into horizontal asymptotes anyway. d2f dx squared equals 0 and only for x is 2 and x is 6. So we've got points of inflection at 2 and 6. So here we've got our, we're curving upwards. Now we have to start curving the other way. And then we got the same thing here. So we're curving upwards and then we need to start curving the other way. Can't change curvature. Yeah, I mean, that seems fine to me. Okay, you could have a horizontal, this is going off to a horizontal asymptote really. But yeah, that's fine. So, I mean, here, the thing with the curvature is that's curving that way and that's now curving the other way. It's changed from curving anti-clockwise to clockwise. Here we've gone from clockwise to anti-clockwise. So that's what this is telling us with these points of inflection. We got one minimum point is continuous. Yeah, so that does mean we could have flipped that over the other way up. We could have had a maximum and then done that and that would have been fine. And we've now just got our asymptote at 0, or well, it doesn't have to be at 0, it could be at 1 or 2 or wherever we want. But yeah, you can have it either way up, so that doesn't really matter. That was quite an interesting question, something different. Right, solve that. Okay, right, a sketch is probably going to help with this, I would have thought. So let's multiply through by x. We're going to have 2 things here. So x, if x is greater than or equal to 0, then we've got minus x is less than 2x squared minus 1, which is less than x. Or if x is less than 0, we're going to have the same thing, but with the signs flipped round. The inequalities, I mean, flipped round. So we've got those 2 options. So if we draw out these lines, then everything is going to be hunky-dory, I think. So, right, let's draw that one. So we've got y equals x. That's these ones. Then we've got y is minus x on the other side. So that's doing that bit, which is these ones. And then we want 2x squared minus 1. So it's a parabola that's been dropped 1. So it's going to go through here I mean, it's been stretched, but that's not really going to show up on the sketch here. So that's the bit in the middle. Okay, so if we are for positive x, we want the bit of the parabola that is between, so it needs to be above the minus x bit and below the, let's change color on this so I can see what I'm doing. So it needs to be above this and below this. So it's between these 2 points is what we're looking at here. We're looking at that region. And then on the other side, I'd imagine it's going to correspond. So we need to be below y is minus x. So that's below here. So that's this bit. And above y equals x. So that's that bit. Yep. So they're the 2 areas that we want. We want these 2 bits. So we just need to find where they're going to intersect with each other then. So we've got 2x squared plus x minus 1 is equal to 0. And then we need to do it again with, well, it's going to be a minus in the middle. So we need to solve that. And then we need to solve 2x squared minus x minus 1 is equal to 0. So that is 2x, we've got minus 1 and x plus 1. So that is x is equal to a half and minus 1. Okay, so that is, well, this point and this point. So that's at minus 1 and that's at a half. And we're going to get the reverse of that for this one, aren't we? So it's going to be 2x plus 1, x minus 1 is 0. So x is minus a half or 1. So that's going to be these. So we need our solutions to be x is between minus 1 and minus a half, or it's between a half and 1. Right, that was fine. I find the graphs really do help, particularly as it takes out all this stupid let's square everything to avoid flipping signs around. Yeah, we're drawing out, it doesn't matter that you've changed the direction in the inequalities, we've still just got 3 functions to sketch out. And then we just look at what region it is for each one. I mean, everything's got that symmetry about it. And it makes solving the inequalities just so much easier. Right, so that's good. Right, now we need to sketch this. Okay, now let's go through the usual steps then. So as x goes to infinity, what are we going to have? Y is going to tend to, what is it going to tend to? Minus infinity squared over infinity squared. So it's going to tend towards minus 1, but it's going to do it on the slightly negative side because we've still got another minus infinity. Okay, it's not squared, but we've got that on the top. So as x goes to minus infinity, y is going to go to, what's going to happen is it's going to be the same, but on the positive side, because we're still going to have that minus 1, but this time this term there is going to be positive, so we're going to be on the positive side of minus 1. So we've got this asymptote, horizontal asymptote at minus 1. Right, so as x equals 0, y is going to be infinite. Right, so we've got a positive y goes to infinity. Right, let's start marking some of these things on. Let's draw, we know we need all of these things. So we've got an asymptote up here. We've got an asymptote here at minus 1. When we're on the positive side, positive x, we're on that side. When we're at negative x, we're on that side. So what happens either side of x is 0? If you've got x is very, very, very small, but negative, then we're going to be on the positive side because we're going to have 1 take away something tiny over something positive. And if x is negative, positive 0, then we're going to get 1 minus something tiny over something positive. Right, so we're up there. Right, it looks like the left-hand side of this graph is going to be pretty straightforward. Is what's going on the right-hand side. We're going to have a turning point, and we're going to have y equal, so y equals 0 means that we've got 1 minus x squared is equal to 0. So x squared plus x minus 1. I find it easier looking at it that way around. So yeah, we're not going to get this factorising. So we need, I suppose it depends whether we actually care about getting this. But anyway, still, x is going to be, so minus b is minus 1 plus or minus, so b squared is 1 plus 4 root 5 over 2. So we've got that value there for the intersection, and then, well, 2 values for the intersection. So that's quite nice. So at least we've got 1 on either side and we know what they are. So we must end up having a turning point. So y dash is going to be equal to, well, we got x to the minus 2, so that'll be minus 2 x to the minus 3, and then minus x to the minus 1, so plus x to the minus 2. So we need that to be equal to 0, which means that we've got, so let's multiply all of these things through by each other. We've got 2 over x cubed equals 1 over x squared. So 2 is equal to x. So, okay, we've got a turning point when x is 2. Right, this is all fitting in fine. When x is 2, we've got y is equal to, so yeah, x is 2, y is equal to 1 minus 2 minus 4 over 4. So that is, what is that, minus 5 over 4. So yeah, we've got pretty much everything here. So this we know is just doing that, going through minus 1 minus root 5 all over 2. This is going through minus 1 plus root 5 over 2. It's got a turning point there going off to an asymptote. So it's doing, that was meant to be a bit more continuous than that. And that is at 2 minus 5 over 4. So yeah, we're just going through the usual steps of when we're sketching out a graph. What are our intercepts? What are our asymptotes? What happens when x is 0, when x is plus or minus infinity? Just looking slightly on either side of each asymptote just to see where we are. So it's a challenging sketch, no doubt. I mean, that's not an easy one. But yeah, we're just going through the same process. They seem to have dropped the graph sketching questions in recent years, but it doesn't mean to say they aren't going to suddenly come back with a vengeance. So, and they're quite nice ones to practice. They're, you know, it's like doing a Sudoku or something. You go through the same process and get a nice satisfied feeling when you get to the answer. So yeah, that was a long set. That was quite a tough bunch of maths questions again, as they were at this time of the PAT papers. So I'll leave that there because that's already gone on too long, and come back with the physics ones soon.